Good morning, everybody. I'm going to really try not to breathe in here. So thanks a lot, everybody, for being here this morning, and thanks, Sarah, for the introduction. So yeah, what I'm going to talk about today is machine learning for front-end devs. I've already been introduced, so I'm not going to talk about me too much. But so my name is Gerard. I am a developer. What is funny is that I'm also unemployed. So it's kind of like, I'm in between jobs as well, but it was quite funny. It's like, come learn, the web from unemployed people. Yeah, good concept. It's like unemployed conf. But outside of my job, I'm also a Google Dev expert and a Mozilla tech speaker. So I know that there's a few other Mozilla tech speakers around. So if you have any question about these programs, feel free to ask afterwards. But one thing that wasn't mentioned and that is really actually important for this talk is that I am not an expert in machine learning. So I know that talking about machine learning and coming here and say, I actually don't know anything, is not a great way to start. But I think it's interesting for two reasons. First of all, it means that I do all of this stuff outside of work on my own time. And if I manage to actually understand a bit of it and build prototypes, I'm 100% sure that anybody here can actually do that as well, which is really exciting. And second, it means that as I don't have a background in data science, I try to explain all of these concepts as clearly as possible so that as JavaScript dev, we actually can understand what's going on. The slides are already available online if you want to check it, maybe because people at the back might not read the code samples really well, but I also will share them on Twitter later on, so I haven't actually started the talk, so you don't know if you're going to be interested, but I will share it later on Twitter if you want to have a look. So let's dive into it. What is machine learning? Obviously, I don't know what you know or don't know, so I wanted to start with a really simple example to put everybody on the same base so that the rest of the talk will make sense, hopefully. So if we think about an example of trying to recognize spam emails, I can safely assume that we all receive spam emails. And if we think about a way to deal with that problem without thinking about machine learning. So when we receive spam emails, they usually contain certain words, like Viagra or lottery, or like, you won millions of dollars. Usually that's not what goes in your normal inbox, that goes in the spam one. And if we think about solving that problem in the traditional way, we might have a list of words that we kind of assume are going to be in spam emails, and when we receive a new email, we might gotta check the content. And if it receives Viagra, then, maybe put it on the spam. I don't know what you go for, but this is where machine learning can actually help. Using a lot of data from previous emails that we have received, knowing the ones that are spam and the ones that are not spam, we can actually use algorithms to create models that will be able to learn patterns from emails. And getting a new email, it will be able to classify directly, automatically, if it should go in the spam box or the normal inbox. So this is basically like the definition of machine learning. It's like using algorithms, letting computers learn from data, and predict things without telling it exactly what to look for. So at the core of machine learning models are algorithms. So let's dive into that. So here are a few examples of different algorithms. It's only 5. There's a lot more out there, but if you start looking into machine learning, doing tutorials or watching videos, you will probably hear about a few of them, like naive Bayes or k-nearest neighbor. These ones are kind of like well-known. And they're all good at at solving different problems. So before thinking about which algorithm you want to use, you might actually think about what type of problem you're trying to solve. So let's look at these ones instead. So in machine learning, you have 3 main problems that you can solve. You have supervised learning, unsupervised learning, and reinforcement learning. You might also hear about semi-supervised, but that's kind of like between supervised and unsupervised, so I didn't talk about it. But in this particular presentation, we're just going to cover supervised and unsupervised. First of all, because I only have half an hour, so that's really a short amount of time to explain everything. But also because most of the time, if you want to build something at work or on the side, it is really easy. It usually fits into a supervised problem or unsupervised. So let's talk about what supervised is. So you create a predictive model based on a set of features and labels. And there's 3 important things in this definition. So what is a model? And what are features and labels? So if this definition doesn't really make sense, it's good to start with an example. And a classic example of supervised learning problem is predicting the price of a house. Let's say that you have a house and you want to sell it, and you don't know exactly how much you should go for. So if you have data of all the houses in the market, your labels are going to be how you classify each entry in this data set. It would be the price, because what you're trying to actually predict is the price. So that would be your labels in your data set. And the features would be the characteristics of the entries in your data set. So in terms of houses, it would be the number of rooms, windows, floors, does it have a garden, which neighborhood it's in, and stuff like that. And using this data set split between features and labels, you can use algorithms to learn kind of like the correlation between in the characteristics of the house and how much it goes for, and create a predictive model. And the model is going to be a mathematical representation of the outcome of your training. So it's going to be kind of like a function that takes as parameters the new features of a house it's never seen before, and from what it's learned from previous data, is being able to predict a label as an output. So you'll be able to kind of have a price that your house should go for based on what the rest of the data from the market. So this is for supervised. But then you have unsupervised. And the difference is that the ability to create predictions, but only based on a set of features. And the end of that definition is really like important because it will really define the type of problems that you're solving. And an example of that is predicting customer behavior. So in unsupervised learning, what you usually try to do is cluster things together. So you're not trying to predict really a label as an output. You're trying to group things together to understand patterns of behavior. Depending on what you buy, you will fit into a different type of category of people. And looking at buying patterns of people who are like you, they'll know exactly what to recommend you next or what to send you advertising for. They can predict what you're gonna buy in the future, and they can target you more easily. So these two examples of predicting the price of a house and predicting customer behavior, it might not be something that you're super interested in, but there's actually a lot that can be done with machine learning. It's not only kind of like data crunching. So let's talk a little bit about applications. I put together a list of things that I thought were interesting that I found when I was researching. There's obviously a lot more. I wish I could do an entire talk just with examples. But the first one that I'm going to talk about is something that actually Sarah Drasner built, so I feel weird I'm going to explain to Sarah what she built. It's like mansplaining, but so I mean, well, I'm going to just explain it quickly, and I guess if you want more information, I think Sarah should probably explain it better. But using image recognition, detecting what is on an image, and being able to dynamically generate the text that should be in an alt tag when you build websites. So I thought that was quite interesting because you could like dynamically set up some process when you build websites. But not only. There's a few, like recently I actually saw this example, so not safe for work JS, where it uses as well image recognition to see what's on an image uploaded, and if it contains kind of sensitive topic, it blurs the image out. I thought it was awesome because I used to work in advertising, and sometimes you create competitions where people have to upload photos based on like a brief, and then you select a winner. And the thing is that you never know what people are going to upload. And I'm sure that sometimes, you might have some weird stuff. And you could use machine learning to kind of have a pre-filtering step instead of having to do everything manually. So I thought it was pretty interesting. But then you also have really interesting thing for accessibility, for example. So I'm not going to pronounce the name of this guy because I think I would do it terribly, but I put the link if you want to read his blog post. And so he was talking about how if the future of interactions are voice interactions, what about if you can't speak? What about for the people who actually can't interact with that kind of interfaces? So he used machine learning and the webcam feed to actually train algorithms to create a model that would recognize some gestures and map that to words, so he could actually interact with Alexa with sign language. And to me, that really is one of the examples that can show that technology and machine learning can make some people's lives a lot better. But then you also have exciting things like games. So this one is not a web-based game, but I thought the idea was just amazing. Being able to train a machine learning algorithm to recognize some gestures and being able to play Mortal Kombat with your actual body, rather than just being restricted to your keyboard or a controller, which I always found quite unnatural and a bit shit. So you could be a lot more immersed in the game by playing with your own movements. So we can see that machine learning is a lot more, I find it a lot more exciting than just, fraud detection or something like that. And it can even be used for things like art. So I don't know if you saw this example, but I think it was about 6 months ago, it was all over the news, because this painting was generated with machine learning algorithm. So a group of people actually cloned a repo from GitHub, like René generated this painting, and it went for more than $400,000 US. And I was like, well, if that's all I have to do, then, no wonder I'm unemployed, I'll just do that, sell art. But I thought it was really interesting because even if you don't really like art, it started creating some discussions around, is it really art if you use machine learning? And if it is art, then who's the artist? Is it the person who wrote the algorithm? Is it the person who thought about using the algorithm for art? Is it the computer? But it's kind of like, I really like the type of conversations that machine learning are even creating. But we are at JSHeroes, so let's go back to JavaScript. First of all, why would you want to do it in JavaScript? So one of the things that I'm the most excited about is that it's accessible and there is really an easier learning curve. If you are interested and you're just a web dev, the fact that sometimes you have to learn a new language like Python might actually block you from even trying, which is a shame because I think it's a topic that's really interesting. And knowing that there are some frameworks that you can already use in JavaScript, it means that it will be the same thing that you do on your normal job. Like, for example, if you decide to migrate from React to Vue, then you read the Vue documentations and you build your website. And it's the same thing with things like TensorFlow.js. You read the documentation, you might have to learn a few concepts, but at least the language you already know it. It's just about learning the framework. Secondly, rapid prototyping. So that's a lot of the things that I do on my personal time. I come up with some kind of like ideas, and knowing that I can just spin something quickly in JavaScript just to validate that what I want to do is possible is really, really interesting to me. And if you have an idea in machine learning and you just want to convince somebody that it's possible, you can just do something in JavaScript in a few hours or a few days, and then move on to something more robust if you want. And then finally, I really like the ecosystem that's around machine learning in JavaScript as well. You have some main frameworks, but you also have people trying to build frameworks that that get you help started a lot faster. And also you have a lot of different modules. You have people porting Python, algorithms written in Python to JavaScript. So I think it's a cool time to actually get started with it. But what can you actually do? So you can import an existing pre-trained model, so a model that can solve a specific problem already trained with a set of data. You can also retrain an imported model, what we call transfer learning. So you start with an imported model, but then you added your own custom examples on top of it, and you just leverage what the algorithm was built for. And finally, you can define, train, and run models entirely in the browser. In terms of tools, you might, that's only a small sample as well, but you do have TensorFlow.js, which is the main one. But you also have ML5. That's a little bit less well-known, but sometimes it's easier to get started with it because TensorFlow has some concepts that are a bit hard to understand, and ML5 tries to abstract that, so you can just get started quickly. Some of the documentation for ML5 is not finished yet, so they're building it as they go, but there are still quite a few things that you can do. And then you have more specialized frameworks, like the one in the middle, Magenta.js, which is for machine learning and creating music. So that's quite interesting. And then, of course, you have the cloud APIs that you can use as well to get started. So, demo time. So I built a demo for each of the things that you can do in the browser. OK, so let's start with using a pre-trained model. Let me just exit, because I have the demo running here. OK, I'll just do that. Yeah. View, full screen. OK, so this thing that I built here, that's one of the most recent things that I built. And it was to use machine learning to recognize an object in the camera feed and help you know if you should recycle it in the yellow bin and the red bin. So I don't know about Romania. I don't know what kind of bins you have. But in Australia, the yellow one is for recycling, and the red one is for the general garbage. So I need to stop breathing. OK. So, oh, geez. All right, so it was supposed to be a mobile experiment. So, well, it's responsive, but you can't really. So that button says, is this recyclable? And I'm getting out of the video feed because it's still a bit dumb. So if as soon as it sees my arm, it's going to think that this is a person. I mean, like I'm a person, but this is not what I wanted to see. So if I say, is this recyclable? Oh, is it a bottle? Yes, and then it tells me, put it in the yellow bin, yay! All right, so, oh, lovely. I need to stop, I really hate that. And I just closed my presentation. Well, that is awesome. All right, well, let me just start again. I was right here. So let me show you the code sample to do this one. So as I said, I used the pre-trained model. So the first two lines, I used a model called Coco SSD, which is an object detection model, and I also imported TensorFlow. Then you just load your model in your application. You get the pixels from the webcam, so you get the video element, and then using some of TensorFlow's methods, you read the pixels, and you kind of just shape it to the way that the model is expecting it. And then finally, you run, you kind of add all this data to your model, and you detect, and you get a prediction. So in terms of just image recognition, that's it. Like there might be maybe a line or two more, because it's just a code sample. But in just the machine learning part of the app, that's it. I felt like I did nothing. The rest of the application to put it in yellow bin or red bin is more normal software engineering, where you build a list of what you know should go in the red bin and yellow bin, and you just match them from the predictions that you get from machine learning. So that is really cool. The first thing that you can do, you can actually get something started really fast. The second thing is transfer learning. So as I said, you use a pre-trained model, and you just add your own examples. So what I built for this one is something that I call the teachable keyboard. So I'm just going to leave it like this. OK, so what I did is, so I'm going to start training. I use the camera feed as well. here. Well, that's really small. OK, sorry. So I'm here in the camera feed, and I'm going to click right, and I'm just going to move my head like that, and I'm going to train examples. Then I'm going to the left. Then I'm going to down. And then I'm neutral. And I'm just going to test to see if it's right. OK, neutral, down, left, right, cool. And then I'm going to start my prediction where I have a keyboard, and I'm able to just write by moving my head. And when I go down, I write the letter, and I go left. And I've actually built this experiment, not for me, because I can type and communicate, but you do have people who don't have the same abilities. And in like just 30 seconds, you can train somebody to actually write stuff. Well, that word doesn't say anything. Maybe it's a word in a language. But like you're able to actually give the ability to somebody to speak without having to do anything else. You just trained a few buttons, and so it might not be for somebody like for you, but maybe somebody in your family does not have the same ability as you. And knowing that you can build that kind of stuff in JavaScript in the browser really quickly is just amazing. Like, I love it. So let's go back to the code sample. For this one, I used another image recognition model that is called MobileNet. I used TensorFlow as well, and you need a classifier to classify new inputs. Here, I just declare some variables where the number of classes. I have 4 because I have right, left, down, and neutral. So you decide the size in pixels of your camera feed, the k value of the k nearest neighbor. I'm not going to go into how this algorithm works. I'm sure that other people online do it way better, but it's quite important as a variable. Then you have your classes. Then you instantiate your classifier, you load your module, you do the same thing as before where you get the data from the webcam feed, and you add that to the MobileNet model that was already trained. So you kind of merge your unsamples with the MobileNet module, you add that example to the classifier, so you kind of retrain the classifier with new inputs, and then you're able to predict the class based on the class that you defined at the beginning. And in the end, you just dispose of the image, because once you already train your classifier with new inputs, you don't need to keep the data from the webcam anymore. So that's pretty much it for transfer learning. Again, it's just a code sample. There's probably a few more lines. But in terms of concepts, that's pretty nice. There's a lot of things that you can do with that. I think that's probably the most thing I'm excited about for the browser. And then finally, doing everything in JavaScript. All right, so this demo is a bit, all right, we'll see how you take it. But so I've had good reactions, but I think maybe people just didn't tell me it was a horrible idea. So what I built was a Wheelie detector. So if you don't know what a Wheelie is, you will know very soon. I'm not talking about pictures. I'm talking about drawings. And then second, let me tell you just before why I built that. Yeah. So I built that because I wanted to build something else where I wanted to allow people to draw on a web page and have it dynamically displayed on like a matrix of LEDs. I just wanted to build a little installation, and I'm just like, if I let people draw on a canvas on the web, I know that some of them are going to draw Wheelies, and I'm not going to be able to stop them. I won't even know if I'm not looking at the thing, if I want everybody to be like remote or whatever. So I'm going to use machine learning to do it for me. So demo, and this is small as well, but hopefully you'll see. You'll be able to try it. So if I draw a candle, I'm terrible. Oh, look at that. And I predict. It's like, it's not a Wheelie, yay! But, I know. It's a Wheelie! Yeah. All right, so it's like my best creation. So what is important to know is that at the moment, it only works with candles and Wheelies because I only trained it for that. I didn't have the time to do anything else. But I'm going to talk to you about the whole process of how I made that, because it was really interesting. I learned a lot because I did everything from scratch. So the first step that you have to do data collection. So I know. So on the right, you have the open source data set that's called QuickDraw from Google, where they had this experiment online where you could draw little like stuff, whatever they told you to draw, and they were saving the sketches. The thing is, it didn't have Wheelies. Actually, it did have Wheelies, because I told you if you let people draw stuff, they will. But the thing is, the data set didn't really contain. I think they tried to filter it down. So I had to draw some myself, because I can't ask an algorithm to know what a Wheelie is if it's never seen one before. So I drew quite a lot, but not as much as I should have to train the model. But I don't see myself drawing thousands of Wheelies. It's not really what I want to do. But I built a little bit of that just to get to an accuracy that was quite right. So the first step is data collection. Then you have to do data processing, because the QuickDraw data set, image is 28 by 20 pixels, but when I drew it in the canvas, it was 200 by 200. And the thing is, you have to have the data in the same format. So I just shaped it down to 28 by 28. And then when you have all your data together, 100% of it, you have to split it between training set and test set. So usually you do an 80%, 20%. And it's important because you're going to take your training set, you're going to give it to your algorithm to generate the model, and then using your already labeled test set, you're going to kind of like test your data against the predictions of the model to see that it's right. So if the label coming out of your prediction is the same as the one in your data set, you know that you did something right, and the accuracy should be as close as 1 to possible. So it's between 0 and 1. But yeah. So you try to get the accuracy as high as possible. And once you have all your data, you pick your algorithm. So I used a convolutional neural network using Keras. So what I need to say here is that the first time I built this prototype, the model is actually in Python, just because I wanted to learn Python, so I did it. In the code samples I'll show later, I've tried to translate the Python algorithm model to JavaScript, so I'll show you a bit later. But at the moment, it is still in Python, because my accuracy in JavaScript wasn't as high. I think I did something wrong. But so once you pick your algorithm, you have to do what we call parameter tuning, because you can't just use an algorithm and give it data. There's actually quite a few parameters that you have to set. Then you do your training, you get your prediction, and depending on the level of accuracy, if it's, for example, just 0.2, you're going to just repeat these steps. You're going to tune the parameter, eventually change the algorithm. It's more of an art than a science. You'll never get it right the first time. But basically, you do all of this. In terms of code sample, so that's really just a sample though, because that to create a model you need a bit more lines than that. But you have like a function to create your train set and your test set, where you use methods in TensorFlow like to create what they call tensors. I'm not going to have the time to go into that, and I think the documentation of TensorFlow is pretty good. So I think they do a better job than me. So I would really advise you to look into it. But once you have your training set and your test set, you can create your model. I decided to have a sequential model. I can't explain why. I just think it was good. And then you can add different layers. And in neural networks, that's where also it's more of an art than a science. It's like the number of layers is a bit arbitrary. If you get to a good accuracy, then you might have the right layers. So you could have, I think I have like 4 or 5, but you could have like 10, but then it takes longer to train. So it's a bit like it's a thing where it's kind of like trial and error. You see what works, what gets you the best accuracy, and then you generate your model. So here we have the model. And then we get our training data. We fit the data into the model to start the training process. Then we get the test data, and we test it again, the model that we just created. And if our label is the same as our prediction, then we're right, and we can actually save the model to JSON and use it in the browser like the first example that I showed you using a pre-trained model. So it's all good, but there are definitely limits that I think are quite important to talk about. So first of all, you need a large amount of data if you don't use a pre-trained model. There are a few open source pre-trained models that you can use. The thing is, if the ones that are out there are not actually fixing what you want to solve, you're going to have to generate your own data. And when I say a lot, like a big amount, it's usually thousands and thousands of samples for an algorithm to get to an accurate point of predicting things. It can take a lot of time to train your own model. Depending on what you're trying to do, sometimes I was just trying to mix images together, like learning patterns from images, and it took me 8 hours to train my model. So it's really, really long. As you go, it will go a bit faster, but that's why I say maybe don't do it in the browser, even if it's possible. Think about the mobile experience. So models are actually quite heavy, like a few megabytes. So if you think about loading that on a mobile network, you're going to lose quite a lot of data from the people using your applications. And in terms of loading time, it's quite terrible. So even if it's possible, I think things are getting better. So I'm kind of really excited to see where it goes. But really think about the actual experience. In terms of hardware as well, your computer is going to run, it's going to be fine. But on mobile, it's going to get it quite hot. Liability. So this one is quite interesting because depending on what you want to build, you kind of have to know why your algorithm predicted a certain thing. If you want to work in fraud detection or letting people have a loan or not have a loan, if your customer doesn't actually like the answer that you give them and they sue you, you can't really go to them and say, well, the machine said no, like whatever. That doesn't really work. You have to be able to explain why your machine learning algorithm said no. And then finally, and really importantly, bias and ethics. It is a really, really interesting, like fascinating topic. So I would really encourage you to learn a bit more about that. But sometimes when you use a pre-trained model, for example, image recognition, you don't know the sample of data that it was trained for. And a lot of the times, especially in computer vision, it was trained on white people. The thing is that not everybody's white, and it's important to include everybody. And so just make sure that if you are using a pre-trained model, maybe try to check if it works with everybody. One thing to really remember is that algorithms are not biased. We are. If you read in the media things like, oh, Google created a sexist algorithm, it's like, it's not the algorithm that's sexist. Like, we have to stop. It's just code. Like, it's not, code can't be sexist. You have to also admit that we all have bias. And what I like about machine learning is that it can raise some points that we have not thought about before, and we can actually get better at understanding our own bias and fixing things. One example here, I don't know if you'll be able to see, but you can check later, is that Google Translate was translating a gender-neutral language like Turkish to a gendered language, a language like English, and the words hardworking and lazy were all of a sudden gendered. And it's like, he's hardworking and she's lazy. And I was just like, but the thing is that it's not Google, it's not the engineers, it's not the code. It's like, what Google Translate is trained on is things that we put on the internet. Like, we just have to be honest that, you know, we do not always write things that are right. And I like the fact that seeing things like this will raise some questions and actually eventually some conversation. It will help us hopefully get better at this. A few tips if you want to get started. So avoid training your model in the browser. So I know that I showed you that it was possible. I still don't think it's a great idea at the moment because it can take too much time. I think a good way to train, a good reason to train your model in the browser is that if you want to visualize the training process. There are a few tools out there that help you see in graphs like how your accuracy is going as you train different steps of your algorithms. So I think that's a great way to train your algorithms in the browser. Otherwise, I don't really see a point. Don't forget to retrain your model regularly. Depending on what you're trying to predict, you actually need new data from the environment all the time. If you're trying to say, oh, I don't know, I have a supermarket and I want to know how much I can sell my avocados for example, you have to look at, for example, data from the weather or data from the economic situation. You know, if there's a crash, people might not want to buy an avocado for $10. But like, it's just about, even if your model is trained once, things change. And retraining it over time will give you a better prediction and better accuracy. Start small is what I usually say to people if you want to experiment with new technology. I feel like there's a lot of things that you can build with machine learning that are just amazing. But if you start too big, you probably will end up nowhere. There is nothing wrong with starting with the hello world of machine learning, which is just recognizing handwritten digits. And also, check the quality of your training data. There are open source data sets out there. So it's really tempting to just be like, oh, I'll just use that and just, you know, play with it and build something. The thing is, like, open source doesn't mean that it's great. Some of the data out there is just not good. And the thing is, if you just use it as it is, your predictions are just going to be wrong. So make sure that you check what your training data is. The resources, so yeah, I put together a lot of links. So the tool of tools, I'm not going to talk over it. I think you can see it afterwards. So yeah, so there's a lot of tools. A lot of like just useful links around some courses that you can do online or some books that you can read. I think one of my favorites is the Ethics and Governance of Artificial Intelligence by MIT, where actually made me realize a lot of things with bias and AI that were super interesting. And finally, a data set. So just to make it easy for you if you're interested, I put together a list of open source data sets and pre-trained models that you can use in TensorFlow. And OK, so that was it for today. I know that it was probably a lot in half an hour, and I cut down so much of what I wanted to say. It was like heartbreaking. I was like, I want to show this and this, but so I hope that it made sense, because I know that it's not something that you might do on the job, but at least now, hopefully, you kind of understand. If you get into a conversation about machine learning, you'll be able to understand some of the concepts, and hopefully, you got a little bit excited, because like there's some things that I started building with machine learning in JavaScript that I'm super excited about. That would probably be like a topic of a next talk, but I think that what can be done is just so exciting and incredible. So that was it. Thank you very much for listening, and thank you so much, JSHeroes, for having me, because I can't believe I'm still here. Thank you.